back to another Miss Pollard Math YouTube video. Today we're going to be going over solving exponentials and simplifying fractional exponents. So something we're going to have to look at when we're solving our exponentials is the bases. We want to make the bases become the same if they're not already. So I'm going to show you a problem where we're going to have to manipulate the equation to be able to get the bases the same to continue our problem. So we have this problem up here that's 8 to the 5x equals 16 to the 3x plus 4. And I want to get their bases to become the same. The bases here are 8 and 16. We want them to be the same number. My first step I always do is look, we have 8, 16. 16 is my bigger exponent. So I'm going to try to change 16 to become in terms of our smaller base. Well, can we write 16 in terms of 8 to some power? Unfortunately, we cannot. 8 to the first power is 8. 8 to the second power is 64. That's not 16. So we cannot write it in terms of 8. So we have to think of another number that 16 and 8 have in common. Well, they both have 4 in common, so let's try this. Can 8 be written as 4 to some power? Unfortunately, not as well. If we have 4 to the second power, that's 16. That is not 8. So one more time, let's find a number they have in common. They have 2 in common. So can I write 2 to some power for 8 and 2 to some power for 16? Yes, I can. So I'm going to write 8 as 2 to the third power, 2 to the 5x still, and then for 16, that's 2 to the fourth power, and I'm going to leave the exponent as 3x plus 4. Now we have to think back to our exponent chapter, where we have a power to a power. So I am going to multiply those two exponents together to be able to simplify this. So this becomes 2 to the 15x equals, we have to distribute to both terms. That's the most important part here. A lot of people get these answers wrong because we're not multiplying it to both terms. So this becomes 2 to the 12x plus 16. Now we have the same base, it's simplified, everything's good to go. Once we get the same base, we are going to get rid of the bases and just solve our equation like we normally would. So I'm going to write 15x equals 12x plus 16. And I'm going to solve this equation. This is a variables on both sides equation. I'm going to solve it for my x. So I subtract 12x over and I get 3x equals 16. So x equals 16 thirds. My students are used to me giving them integer values. As you can tell, you can get a fractional answer. I'm going to stick with on my quizzes and assessments just the integer values so we are not getting as confused. But this is how we would solve the process. Let's take a look at another problem to solidify our knowledge on this material. Now we have this problem. We have 1/3 to the x plus 2 equals 9 to the 3x. And this might seem a little bit crazy in a sense because we haven't seen a problem with a 1/3, a fractional base raised to an exponent. But once again, what I like to do is look. We're going to look at the denominator and compare it to the 9 here. We have a 3 and a 9. Can 9 be written as 3 to some power? Yes, it can. So let's write it like that. 9 can be written as 3 squared. And we have the 3x still on the outside. Now I want to write 1/3 as 3 to some power. And we once again have to think back to our exponent rules. Our exponent rules, we know if we have a negative exponent in the numerator, it comes down to the denominator, it becomes positive. Well, that's the same vice versa. If we have a positive exponent and we bring it to the numerator, it becomes negative. We can see we have that imaginary 1 as the exponent on the 3. So when we bring that up into the numerator, it becomes negative and becomes 3 to the negative 1. So we're going to have 3 to the negative 1, and then we're going to have x plus 2 as our other exponent and set them equal to each other. Once again, we have to simplify this. So this becomes 3 to the negative x minus 2 equals multiplication 3 to the 6x. Once again, you can tell I multiplied it to both terms. It has to be distributed to both terms in that binomial. Now we have the same base, so I'm going to set the equation equal to each other, those exponents equal to each other. So I get negative x minus 2 equals 6x. A variables on both sides equation. I'm going to add x to the other side, and I get negative 2 equals 7x. So my x is negative 2/7. What's mainly important is the steps. It's okay I got a fractional answer. As long as we were following the steps properly, we are good to go. We have to recall that if we have a number in the denominator, it technically has a negative exponent in the numerator, and that's how we would solve this problem. Let's take a look at a problem when we're simplifying fractional exponents. Now we have a problem that says 343 to the negative 2/3 power. And we're going to use that same concept I said before about moving our negative exponent into the denominator to make it positive. We never want negative exponents. That's not proper. So I am going to act like this is this divided by 1. And when I am going to make that positive, it's like I flip that fraction and then make it positive. So now this is going to become 1 over 343 to the 2/3. And a very important key point here is to realize, what does the 2/3 mean? Well, when we're raising it to the power, that means the denominator is how many times we're rooting it. So if it was a 2, we were square rooting it. 3 means we're cube rooting. We're cube rooting 343, so let me write that. 1 over the cube root of 343, and then we're squaring that. So to restate this, we put the 3 on the outside for the root. We put the 2 on the inside because it tells you what to square. So denominator, how many the roots. The numerator is how many times we're multiplying it by itself. So I'm going to show you a video inside this video. How to compute this on our calculator. I'm going to plug this in now, and I'll show you how to do it. But what we're going to do is first find the cube root of 343. So I put that in my calculator. Some of these problems you might be able to do in your head. This one's a little hard, knowing the cube root of 343. And that gives me 7. So when I cube root this, I get 7. So now we just have 1 over 7 squared. And we can do that in our head. 7 squared is 49. So my final answer is 1 over 49. And I'm going to insert a video here on how I solved it on my calculator.
So this is one of the type of graphing calculators you may see. We have a different type in class, but the processes are very similar. So I'm going to show you how to complete this. So for this calculator, we're trying to find the cube root of 343. And on our other calculator, the way we're going to do it is there's going to be this up arrow next to the 7. So I'm going to click the second, click that up arrow, and that will give me to the cube root like I want. But for this calculator, I'm going to put my 3 first, just like you would in the calculators in class. And then for this one, I would go to the math button. Once again, for the one in class, I would click second. And then I would click the up arrow, which is over here. And that would give me the cube root. For this one, I'm going to click math, scroll down, and click this one. Of course, it would make most sense to do number 4 up here because we're doing the cube root. But if I'm doing the 5th root, I would do 5 and then 5 here. 6th root would be 6 and then this. So I might as well just stick with this so I know how to do it every time. So this gives me the cube root. On the problem, we have 343, and then I press enter and I get 7. Now I want to get this squared. So I would go to this up arrow here, click 2 for squared, and press enter. So many graphing calculators are similar where they're going to have the math button, or they're going to have something where we're able to look above our exponent button and do the root of. So these are the 2 different ways. Then because we have 1 divided by it, it would just be 1 divided by 49. We don't need the decimal, but there's the decimal.
So now this is the last problem we're going to do. And this looks scary. It looks scarier than we think. But let's see what we have to do here. We are going to take the radical and rewrite it into a fractional exponent. So like last problem, we took a fractional exponent and put it into a radical. Now we're doing the opposite. So this has an exponent, that imaginary 1, and we know that goes in the numerator of our exponent. And then the outside, the root, goes in the denominator like so. And then this is going to the 2x power. This is going to equal, we need to rewrite this as well. It has a raised power of 1 and a root of 4. to the x minus 3. Now this is something that we are more comfortable with. We have a power to a power, so we're just going to multiply them together. 1/6 times 2x is 2/6x. However, I'm going to simplify that to 1/3 just to make my life a little easier. So we would get 2/6x, but I'm going to simplify that to 1/3 x equals, and now here I'm going to distribute the 1/4 in, and I get 2 to the 1/4 x minus 3/4 as my new exponent. And if we look, we have the same base. That's exactly what we wanted. Our same base is simplified. So now I'm just going to take their exponents, set it equal to each other to create a variables on both sides equation. So I personally don't like working with fractions as much. So what I'm going to do is clear the fractions. So you can multiply everything by 3, then multiply everything by 4, but I'm going to figure out what the common denominator is. And the common denominator would be 12. So I'm going to multiply everything by 12 to clear this fraction. So you multiply it by 12. 12 times 1/3 is 4x. 12 times 1/4 is 3x. And this gives me 12 divided by 4 is 3 times 3 is -9. I'm going to subtract that 3x over, and I get x equals -9. So this is how we write our radicals in fractional form, and then we're solving inequalities. So we're using both of these concepts that we learned in this video all in one problem, and I hope this helps for these two topics.